This video is going to explore the different ways of factorising algebraic expressions. To be able to factorise, we must understand the different terminology used when we break down an algebraic expression. For example, this 5a is considered a term, and within this term you have the variable, which is a, and the coefficient, which is 5. In a similar way then, our 7 in this term is the coefficient and our variable is y. A variable is the unknown part of the algebraic expression. And finally, you will have 2, which in this case is called a constant. I'm now going to go through each of these 4 parts in detail. And in maths, factorising is the reverse of expanding. So in the previous ones we were expanding and simplifying. We are now doing the reverse and we're turning an expression into a product. So one way we do this is a highest common factor, or HCF. Another aspect of it is grouping. We then have the difference of 2 squares and quadratic trinomials. Up first we have highest common factor. So for part 1, we're asked to find the highest common factor of y squared plus 4y. And straight away, we know what's common. We're looking for something that's common between these 2 terms, which we know is y, because we have a y on this side and a y on this side. And now we need to divide then by our factor, which we have found to be y. And if we remember the rule for dividing powers, we're left with y on the inside of the bracket plus 4. And we have now factorised this expression fully using highest common factor. And for part 2, we will have an x squared minus an 11x. And again, just as similar as part 1, x is our factor because we can divide both sides by it. And when you divide x into x squared, you are left with x minus 11. We're now going to factorise using grouping. So I take my first question. I have the terms mr minus ms plus nr minus ns. And what I need to do is I need to remove the common factor from 2 pairs of terms. So the best way to do this is to split it down the middle. So now I have 2 terms on this side and 2 terms on this side. And now I simply find what's common. So what's common in the first 2 is m, and I have r minus s left over, because I've divided by m and divided by m. And on the same side here then, I have a plus, and what's common is n bracket r minus s. And I know I'm right because these brackets must be the same. And now I simply regroup my factors. So I have m plus n in one bracket and r minus s in the other. Now for part 2, I have ax minus ay minus cx plus cy. And I do the same thing as the previous question. I split it down the middle and I find what's common to each one. So for the first 2 terms, my common factor is a. So I divide by a. And when I divide by a, I'm left with x minus y. And if I was to apply it to the other side, I'm left with a minus c and divide by c x minus y. And I regroup them. So I have a minus c bracket x minus y. And because my two brackets are the same, here and here, I know I'm right. Here we're going to factorise using the difference of two squares. So for part 1, we take the x squared minus 49 and we simply write each term as a square. And when I do that, I get x squared and 7 squared. And if it's not directly clear to you, to find 7, I simply found the square root of 49. And what we say is, we rewrite it in brackets x plus 7 and x minus 7. And if I was to multiply out each term in these brackets again, I will get x squared minus 49. Now to solve part 2, we have a squared minus 225. And again, I put each term as a square. So I have a 2b squared and the square root of 225. When you put it in your calculator, you will get 15. And just like the previous question, we grouped them as a plus and negative bracket. So I have a plus 15 and I have a minus 15. And I have now factorised using the difference of two squares. In these two examples, we now have a coefficient in front of our variable. So we have 4x squared minus 81, and in part 2, our coefficient is 25. And we're going to now solve using the difference of two squares with these two examples. So part 1, 4x squared minus 81. Again, I write them each term as a square. The square root of 4 is 2. So my answer is 2x 2b squared. And I then have 81. And again, the square root of 81 we know is 9. And that's 2b squared. So my answer then, when I regroup them, is 2x plus 9 and 2x minus 9. And if we were to apply that same method to number 2, we have 25a squared minus 144y squared. I write each term as a square, so I have 5a to be squared, and for 144y I'm left with 12y to be squared. And I got them simply by finding the square root of 25 and the square root of 144. And again, just like in part 1, we rewrite our equation, so we have 5a plus 12y, and I'm left with 5a minus 12y. And that is factorising using the difference of two squares when you have a coefficient in front of your variable. We're now going to factorise this quadratic, and the method I'm going to use is guide number. So my guide number in this case is 32. And it's a plus 32. And I'm using that 32 to find the factors that will add or subtract to give me 12. And we know that that's 4 times 8. And when you add 4 and 8, you get 12. So I rewrite my quadratic, x squared, and instead of putting in 12 this time, I'm expanding it and putting in 4x plus 8x, because that will give me 12. And I keep my original plus 32. So I have simply expanded my original. And I now solve the same way I did when I was grouping. I split it down the middle and I find what's common. My common factors here are x, and when I divide by x and divide by x, I'm left with x plus 4. And again over here, I need to have x plus 4, so my factor is plus 8. And I'm finished when I regrouped them. I have x plus 8 and x plus 4. And I know I'm right because both of these factors are the factors I had up here. These two quadratics are slightly different to the previous question because now I have a coefficient in front of my x. So I need to find my guide number because 15 is no longer my guide number because I have a 2 here. So what you simply do is you take the 2 and you take 15 and you multiply them, and that gives you 30. So my guide number is now 30. And I must find the factors of 30 that add or take away to give me 13. And straight away we can tell that they are 3 by 10. Because 3 by 10 will give me 30, and 10 plus 3 will give me 13. So I simply rewrite my quadratic. I have 2x squared, and I put in a 3x and a 10x and 15. And I now simply split it down the middle and solve. What I have common here is x, and when I divide by x on both sides, I'm left with 2x plus 3. And on the far side, I should have 2x plus 3 because my brackets must be the same. So my factor must be plus 5. And I rewrite them. Open my bracket, x plus 5 and 2x plus 3. And I have now solved that quadratic. Try and apply the same method to part 2.